Let us take a look of this problem called metric multiplication problems. Before we go further, we need to understand the basic of matrix multiplications. For simplicity, for simplicity, let's say this n by m, which is 4 by 4 matrix here. So let's call this A and this B matrix. We need to get the product of A and B, which is C here, and we have A 1 2 3 4, B 5 6 7 8, and finally, as a result of this multiplication product of A and B, we got 19, 22, 43, and 50. And if you notice that's the metric multiplication, basically the order is we need to have a here and here. So 1 times 5 here plus 2 times 7, and for to obtain this 19, and next is 1 times 6 plus 2 times 8 to obtain 22 here, and 3 times 5 plus 4 times 7 to obtain 43, and 3 times 6 plus 4 times 8 to obtain 50. If you notice here, um, this multiplication equation, how many multiplication involved? If you count that, we have 1, 2, 3, 4, 5, 6, 7, 8. So this 8 multiplication, in order to compute the product of A and B, we have 8 multiplication. This becomes the basic operations. Okay, look at this in terms of algorithms from the brute force design strategy for the metric multiplications. These are actually the A and B, and A times B, product of A times B. So we need to obtain the C here from the pseudocode here, where we have this array A 0 to n minus 1, and also because there are two array, 2D two-dimensional array 0 to n minus 1, and B another input for the B 0 to n minus 1, as well as 0 to n minus 1 for the two-dimensional array. Multiply two square matrix of order n by the definition based algorithm. Input 2 n times n matrix, n by n matrix A and B. The output will be the matrix C equal to A times B, which is a product of A and B. And if you look at this, we have a three loop here. This I equal to 0 until m minus 1. This j equal to 0 until m minus 1. K minus n, n minus 1. And finally, we need to compute this Cij plus Aik minus Bkj, as we discussed before, in order to get the product of AB here, Cij. And in terms of the analysis, the time MC, basically we end up with this because we have the summation here n minus 1, this I equal to 0, increased by 1. We have another summation here, also n minus 1, and this becomes the j equal to 0 and increased by 1. So another summation for the k, but this also n minus 1, k equal to 0, here minus 1. So this end up with n, finally. This also end up with n, finally. This also end up with n, finally. So this m time n, where we obtain the big O of n cube here. Just now we discussed on the metric multiplications using brute force design technique, end up with n cube in terms of time efficiency. But now we have another solutions called Strassen matrix. But the difference here is Strassen incorporate the idea of divide and conquer to solve the same problem for metric multiplications. This called Strassen matrix in 1969, uh, based on the same problem. Two matrices basically can be computed as follow, where we have the same here, let's say n by n here. We have a product of a and b here equal to c. We have c00, c01, c10, c11, a00, a01, a10, a11, b00, b01, b10, b11. And this is actually the formula that yield the product of C. Here we have a M1 plus M4 minus M5 plus M7. This actually to obtain the C0 here, 0, 0. And we have M3 plus M5 to obtain the C01. And M2 plus M4 to obtain C10. And M1 plus M3 minus M2 plus M6 here to obtain C11, where M1 is here, A0 plus A11 times B0 plus B1, M2 here, M3 here, M4 here, M5 here, equals for M6 here, M7 here. Okay, just now, how many for the brute force multiplication involved to obtain the product of A and B in terms of C? For the brute force, we obtain 7. For here, Strassen matrix, you will reduce by 1 here. In total, for multiplication, we have 1, 2, 3, 4, 5, 6, 7. So 8 versus 7 multiplications using the Strassen matrix employed divide and conquer. And the principal insight of the algorithms lies in the discovery that we can find the product C of two times 2 by 2 matrices A and B with just 7 multiplication, as opposed by required by the brute force algorithm here. And the question now, where is the divide and conquer? So let's say we have here is 4 by 4, 4 by 4 multiplications, and where we have this divide by half, come 2 by 2, A1, A11, A11, A12, A21, A2, A2, A13, A14, A23, A24, A21, A31, A32, A41, A42, and A22. For example, A33, A34, and 43, and 44. The same thing goes to the B. This the idea of divide and conquer. Okay. But now in terms of analysis of Stressen's algorithms, end up with 7 multiplication of time m over m of n over 2, where actually divide by 2 here, because the divide equal m of 1 equal to 1, by using the master theorems here, where 7 we have the 7 here, where A equal to 7, B equal to 2, and D equal to 0 here. So finally, A greater than B here. So we take this condition, satisfy the condition, so become N log A. A is 7 base 2. So become N log 7 base 2, end up with 2 n to power of 2.807 versus the brute force, which is n cube less than n cube. So basically, asymptotically, this algorithm stoichiometrics better than the brute force. The fastest algorithm so far for the same problem in 1987 done by Cooper, Smith, and Winograd with 8 SMC is n to power of 2.376. These are the letters. So you can see here the algorithm design technique can contribute to the efficiency of the better efficiency of the algorithm. The same problem, we have the multiplication from the brute force. When we employ the divide and conquer, stoichiometric yields uh, big O of n to the power of 2.807, and another attempts made by Cooper, Smith, and Winograd also improve the time AC become O big O of n to power of 2.376